All right, let's continue on with tic-tac-toe now. Right, what we just finished was displaying and initializing the board in terms of starting a new game. Right, every time we start a new game, we'll have to initialize the board and then display the game board. Right, we've written code for that, and we can see that here's a sample of what the start of a game might look like. Right, it might be nice if we added some information to our game board that said tic-tac-toe, maybe the players' numbers, and then a prompt for entering a number. So let's see what we can do now to change or to add to the code that we just wrote. And, all right. So we left it off, right? We left off with displaying our game board, right? When we run this, right, we just had this on our screen, but it just said game board. Tic-tac-toe might be nicer to say. Right. All right, now the other example we saw said player 1, X, player 2, O. We don't have to make ours look exactly like that. If we did, well, now we've defined this is 0 and 1. We might have to make some changes to do that. Let's just go ahead and write a function to get the user moved. So all I did was change the title here. So it says tic-tac-toe instead of game board. All right. So we could put this under the heading of start new game as a comment, right? And then initialize game board. Well, I think the name of the function pretty well takes care of that. Displaying game board, that takes care of that. Let's write a function that says take turn or player takes turn, right? Get player move. Player turn. All right. And let's tell it which player's turn it is. That means we probably need to have a variable then to keep track of. Let's create one called current player. And now what we should do is we should initialize current player to X every time we start a new game. So under start new game, let's just say that current player is equal to X player. Let's pass current player to our function. So that knows. That function should probably return the player selection. So let's just call that square. Which square did they pick? Or all right, and let's write the function then. So the user is going to choose a number 0 through 8. So we'll just return an integer, right? This was called player turn. And we had to know who the player was. That goes in our parameter list simply because we're going to pass the current player up here. Right? We're going to do that then so we can display a message saying who the current player is. Right? We could say printf, right? Player. And let's pop open what our screen looked like. So this said player 1. Let's make ours say player X, enter a number. Right? So that's why then the X will get substituted in here for player C, enter a number. Okay. And we want to capture the value that they enter. Now, we might need to space this out a bit below the game board. All right, so we're going to read an integer. We're going to store that at the address of our variable value. And then this function should return the value that we get. All right. Now, what I didn't fill in here, I almost forgot, is the argument here. So the argument here, right? Well, when we pass player, down here, current player, right, is an integer number. So the current player should be X, should be O. Once again, we can use then that display. So this array we made before, this character display array. To determine, right, then whether to display an X or an O. All right. So let's just go ahead, build and run, and see what we get. So for this first one, good, that's substituted in the value of X, right? Enter a number, right? If we type in some number here, right, then our program ends simply because, right, that's the end of our code here. So this means that we got the first move, right? The player and X took his first turn, right? Right now we're just assuming that we're getting valid data entry. Notice then the person entering the information could have typed something outside the range of 0 through 8. They could have typed in some bad data. We're just programming for best case scenario right now. We want to get the functionality of this game up and running. All right. So here we can say X takes turn, right? And actually, now when we get X's move, right, we want to add X to game board, right? And square is the variable that is the location of where we should store the X. So we could just say game board at location square, right? Index square. Then, well, we'll just set that equal to current player, right? Which in this case is X player. And after that happens, right, we want to go ahead maybe and display the board again. To see if that update's working. All right, so let me just enter a 0. And sure enough, we see the X appear in the upper left-hand corner, and our program ends. Right? All right, so that's updating the game board. Right? What we would do next is we would let O take a turn. We know that there's not a winner. So we could just go ahead now and say then, right, player O takes turn. Well, we need to now switch from player X to player O. Right? And we could just say current player equals O player. And then we could perform the same actions, right? We want to go ahead and get player O's move. Then we'll want to go ahead and add an O to the game board. And so if we build and run this, right, X enters a 0, right, comes back up now, and it says player O, enter a number. Well, I'm going to put a 1 in here, so now we get our X and our O. All right. So X and O took turns, right? What we don't have in place yet is we don't have any logic to say, well, what happens if O chooses a spot that X is already chosen. All right, so like I said, right now let's just go best case scenario. At this point, we still don't have a winner. That means then we might have to repeat this whole X takes a turn thing, right? Well, might have to. That's what the game would do. X would take a turn. Right. So that means then, right, I need to set current player back to X player. Right? And if we build and run this, right, you'll notice I'm writing a lot of code that's starting to get repetitive, which is going to suggest we enclose this code in a loop. So here's X's first turn, right? Here's O's first turn. Then here's X's turn. All right. So we have 3 turns of the game now at this point. And in playing the game, right, we'd come back and say, well, we don't have a winner. We'd want to go ahead and then let player O take a turn. Right? Which means then we have to keep, right now, I've copied this code over and over again. What we should do is we should put this in some sort of loop, because we should notice that whenever we start repeating sequences of code, that means we need to write a loop to enclose this. And if you think about what we're doing, we're letting the players take turns until there's a winner, right? Until there's a winner or tie game. And if we go back to then our pseudocode, right? Our pseudocode said, start a new game while game is not over, display the game board and let the user take a turn. Let's come back to this idea then. So we started a new game here. Right, we did all of this. We set the current player, we initialized the game board, and we said while, we want to say while game is not over, right? Game is not over. Now that is not C code, obviously. We want some of these things to happen in there. Right? And I'm going to put a comment that says keep playing game until there is a winner or a tie game. So while game is not over, we need to write some code then to come up with a test condition that this program can handle. That means we need to write a function that checks for a winner. So let's write that check winner function. Now, let's see. I've been keeping up with my function prototypes. Right? We said before function prototype was this function heading here, right? Followed by a semicolon, and then it didn't matter what order we wrote these things in. I'm going to go down here and throw this under initialize game board. I could leave it up there, just kind of getting it out of the way at the top of the file. I'm going to keep up with putting in my prototypes, and then we will write check winner. Right. So there's player turn. All right, let's write check winner here. All right. Check winner then, well, let's talk about what we're going to return. So check winner. Well, we're going to need the game board to do that, aren't we? Right? We will need that parameter of the game board. We know that the length of the game board is always 9, so we don't have to pass it in this special case of this program. All right. So then different ways that we can win, right? 3 in a row. In any of, so it's 3 in a row. It could be this row, could be 3 in a row here, 3 in a row here. Or we could have 3 in a row in any of the columns, or we could have 3 in a row in the diagonal here, right? So let's say, let's check row 1, or check first row. Right. So the first row, right, if we had a winner in the first row, right, we'd have an X, and then, well, we could have an X, Yeah. We could have that. Or if O wins, right, we have, right, our game board looks like, I can't type, looks like that. Right. And these are positions then. If we look at our game board, well, that's 0, that's 1, that's 2. So what we could say here is if, we could say this, if game board at index 0 equals X player, and game board at index 1, right, is equal, just can't type, X player, and game board at index 2, if that equals X player, well, then, right, then X wins the game. Now we could say, oh, well, let's return X player. We could, right, that's our representation of X, so we'll just return X player. Right, X player is an integer data type. That tells me then my return data type here should be an int. Right. So that's what happens when X wins. But we could say, then we could say, well, else if game board 0 equals O player, and game board 1 equals O player, and game board 2 equals O player, then O wins the game, return O player. All right. But we could do that, right? Logically, those are the things that we check for. Now we can write this in a more compact form, right? So when you begin writing code, I'd walk through this logic, probably write this out. After I took a look at it, I might see if there was a shorter way I could do it. I'd say, well, here, look, I'm checking to see if game board 0 is equal to X player, and game board 1 is equal to X player, and game board 2 is equal to X player. Well, isn't that the same then? If game board 0 is equal to X player, then game board 1 and game board 1 is equal to X player. That means, well, game board 0 is equal to game board 1, and game board 0 is equal to game board 2, right? So I can then shorten this. Right? I can now shorten this to say, what if I say, what if game board 0 equals game board 1, and game board 0 equals game board 2, and game board 2 equals X player, then X player 1. Right? And I better spell that correctly. Okay. Well, that means I could do the same thing with O player, right? Because game board 0 is equal to game board 1 is equal to game board 2 when they're all equal to O player. So if I were to then substitute in this here for O player, right? And if I were to substitute in game board 0, I'd substitute this in here. All right. All right, so now when this is true and this is true and this is true, we know that X won. And when this is true and when this is true and this is true, we know that O won. So both of these test conditions look exactly alike, except for this last condition here, where we're checking to see between X player and O player. But if you think about it, right, doesn't the game board, when all three of these are equal, it already contains, we've already stored a representation there of whether or not it's X player or O player. So can I then say, well, if all three of these are equal, we have a winner, right? Get rid of this, but then I have to say, how do I know whether or not it's X player or O player? Well, I know by what's stored in game board. If I return what's stored in game board at index 0, any one of these indices, since they're all the same, do I then have a winner, right? Then, right, I can just say there is a winner, right? Let's compile. Oh, here I use the word game board, but everywhere I name the parameter board. I'm just going to change it. It's faster for me to change the parameter name. And it is here. All right, so we got a compilation error down there. Right, simply because we don't have anything coded in here. So for right now, let's leave that blank. What I'd like to do is after X takes their first turn. So after X's first turn here, let's call our check winner function. It's going to return an int, so let's create another variable to store winner. Right. And here now, we'll say, is the game over? Or is there a winner? Or tie game? So we'll assign the winner. We'll call that function then check winner. That was the name of our function. Right. And we needed to pass that game board. Right. Name of our array is game board down here. We pass it that. Right, so let's take a look at what happens now after this first turn. Okay. Oh, because I commented out that first curly brace. All right. Oh, notice I had not included, I hadn't been paying attention to the warnings. I haven't included this standard input output library, header file for that. All right. All right. So now down here, I'm going to do a run to cursor. All right. Our game board pops up. It's X's turn, player X, enter a number. Well, let's just enter 0 so we have something in the first row. That's what we're checking. All right. Now let me minimize this. So back here, we can see in our array and game board, X is a 0, right? Every other space is initialized to open. So in this case, it didn't tell us there was a winner in the first row. All right, we can see that, well, it shouldn't tell us. Let's just step in here. So we're going to step into our function. All right, now that we're into our function, this will say if game board 0 is equal to game board 1. Well, it won't be because there's actually a 2 in there. All right, so next line, that's false. We come back. All right, so we play the game again with another turn. Now, hopefully you've already seen that there's an error. There's a logic error at this point. Let me just call check winner before we even put anything on the game board. It will show up eventually if we code the rest of it, but let's just go ahead and right away call check winner. All right, even before we take a turn. All right. And notice here, right, we displayed the game board. Just going to go ahead and step into this function. Well, right now, every square on game board is equal to 2. This condition is going to be true, right? This is going to be 2. This is going to say, well, if game board 0 is equal to game board 1, they're both 2s, that's true. Game board 0 equal to game board index 2, that's true, right? They're all initialized to open. This is going to return open as a winner. Right, so if I say next line, and now we say next line, right, we're going to return back to main. Notice now, main has a value of 2 for winner, right? It returned open, right? It returned the fact that all 3 of these were equal to each other, and that really isn't a winner, right? It's only a winner, we said, when we have all X's or all O's. We need to add another condition here that says, and game board 0, right? Since it's equal to the other 2, we need to make sure that it's not equal to an open spot, right? If it's not equal to open, then that means that we either have 3 X's or 3 O's. Right. Now let's go ahead and code the rest of check winner. So if we finish checking the other rows, right, we could say, well, check second row. And to do that, my indices are 3, 4, and 5. And I want to return that. All right. And then we can check the third row. And that's 6. Sorry. 0, 1, 2, 6, 7, 8. Right, those are our rows. And then we can check columns, right? All right, so the first column then is, well, it's not. Let's use this form. So my first column here, give you a little more white space there. All right, so our first column, right, if we go back to what our board looks like, is 0, 3, and 6. Our first column, if 0 is equal to 3, 0 is equal to 6, well, we could return any one of these, right? And 0 is not equal to open, I'm going to return 0. And okay, so now it really doesn't make a whole lot of difference here whether I have ifs or else ifs, because if this is true, this is going to return, meaning it'll completely leave the function. So I can have this as an else if condition here, simply because I always return when something's true. I'll never go down and check those. Well, if this is false, I'll have to go check the others anyway, because its only action would have been to return. So I could have just coded these, I'm trying to say, as regular ifs as well. All right, so let's now check the next column. So check middle column. Maybe this is right. Check left column. All right, so this column, right, is 1, 4, and 7. 1, 4, 1, and 7. And then the right column is 2, 5, and 8. And then finally, we can check diagonals. So the diagonal then 1 is 0, 4, and 8. And the other diagonal then will be 2, 4, and 6. Two. All right, hopefully I haven't made a mistake here with the copy paste. Those are the diagonals. All right, so now if we get all the way down to here, we know, so what we're going to say here, we know there is no winner. X hasn't won, O hasn't won. What we don't know is there a tie game. Okay. So I'm going to say for int I equals 0, going to search the whole array. I less than 9 plus, plus I. And we're going to search, and we're going to say if board at index I, if that's equal to open. So if there's an open spot, right, there is a winner. Or, I'm sorry, there's no tie game, right? If there's an open spot and we have no winner at this point, right, we're just going to return, we could return open, we could return board at I, they're the same thing, they're equal at this point. But now we'll leave this, right? So if we get all the way through this for loop, we know there is no winner and there is no open spot. We're simply going to return tie game. And if I didn't make any silly errors, that should be our check winner function. Now, there are ways to shorten that up. You could try writing a for loop. You can see how some of these indices are related and how they're changing. So you could try writing some for loops for checking rows and columns. All right, but we'll go with this for right now for check winner. All right. And let's see, I had thrown the check winner in up here, which I did that for testing purposes. We really don't need. So while game is not over, and so as long as winner, right, is equal to open, whenever winner returns open, we know that we have X hasn't won, O hasn't won, and we know there's not a tie game. Whenever that check winner function returns open, we do not have a winner, right? So actually, so I can say here, what I did was I initialized winner to open, meaning, right, game is not over. Or we could have it return something. We could have it return something other than open. Maybe we could have a pound define maybe we'll call this play game or continue game. Maybe make that 4. So we could return open and use that as a test condition. But what we could also do is say, well, let's return play game, continue game, we could have called it. And then let's make our test condition here, say, while winner is equal to play game. Now we'll have X take a turn, O take a turn, right? And we'll go back and forth. All right, so let's just stop right here now that we've got check winner. In the next section, we'll talk about how to shorten this up inside the while loop.